Welcome back, coders. Today is day 32 of solving GeeksforGeeks problem of the day. In today's video, we'll be solving a hard level problem where we find the longest valid parenthesis substring. It's a common interview question and tests you understanding of stack and dynamic programming concepts. So today's question is longest valid parenthesis. So the question says here, given a string str consisting of opening and closing parentheses, find the length of longest valid parenthesis substring. A parenthesis string is valid if for every opening parenthesis there is a closing parenthesis. Opening parenthesis must be closed in the correct order. So give an example. The longest valid parenthesis is the parenthesis starting from index 2 to index 3. So the length here would be 2, and in this given example the valid parenthesis substring would be from index 1 to index 5. The length here would be 4. In summary, we are given a string str consisting of opening and closing. Our task is to find the length of the longest valid parenthesis substring, and given here the conditions of a valid parenthesis string. So the brute force approach here would be to check each and every possible substring and verify if it's valid. And the steps would be to iterate through all the substrings of this given string, and for each string we'll check if it is a valid sequence of parentheses or not. So if valid, we'll update the maximum length, and if not, we'll continue with the further substring. So how to check for validity? We'll maintain a balance counter. We'll increment the counter for every opening parenthesis and we'll decrement the counter for every closing parenthesis. So if the balance goes negative at any point, we'll return false from there since the substring is invalid. So let's dry run this example. Given input 1, the following substrings of this given string are as follows here. So we'll check each and every substring using a function valid, and we'll maintain a counter variable which counts every opening and closing parenthesis, and if at any point the counter becomes negative, we'll return from there. So here this substring has just an opening parenthesis, so it is an invalid substring. Same goes with this substring which is invalid, and finally we'll find a substring whose counter variable becomes 0 as it has equal number of opening and closing parentheses. So here the length would be 2. Coming to the second example, the substrings of this given example are these as follows. I've written few, and here we'll find a substring whose the number of opening and closing parentheses are equal and the length here would be 4, and we'll find another substring whose counter variable becomes 0 as it has equal number of closing and opening parentheses, and here the length would be 2. Since we need to find the maximum valid parenthesis, the answer here would be 4. So task is simple. We need to generate all the substrings of a given string, and we'll check using a function that it has a valid parenthesis or not, and if it is valid then we'll calculate the length from it. So let's try to code this approach. So here's the brute force approach. So here I've taken the size of the string. I've maintained a maximum length variable which is initially 0. I've run 2 for loops to generate all the substring, and I've used a function isValid where I've passed the index values and the string, and if it is valid, we'll maintain a max length and we'll compare it with the current length and we'll calculate the max length out of it, and we'll finally return the max length from here. So isValid function works like this. We'll maintain a count variable here. We'll iterate over these two indices and we'll count the opening and closing parentheses, and if at any point the count becomes 0, we'll return false from there, and finally after finishing all the iteration over this substring, we'll check whether the count value becomes 0 or not. If it is 0, then we can return that it is a valid substring, or else it is a non-valid substring. So let's try to compile and run this. Works fine. So let's submit. As you can see, this problem gives time limit exceeded, as the time complexity for this code would be O of n cube, as we are running O of n square for generating all the substring, and another O of n to check whether it is a valid substring or not. So for every O of n square, we are using an O of n way of finding the valid substring or not. So totally the time complexity would be O of n cube and space complexity would be O of 1. That's why we are getting a time limit exceeded for this approach. So we need to optimize this approach by reducing our time complexity, and we can take an external data structure as mentioned here for our expected auxiliary space. So now let's optimize this using a stack based approach which will bring down the time complexity. So here the key idea is to use a stack to store the indices of a parenthesis, and we will track indices where mismatches happen and calculate the length of the valid parentheses based on their index differences. So steps here would be to initialize a stack with -1 to handle the edge case where a valid substring starts at index 0. So for each parenthesis, if it's an opening parenthesis, we'll push it into that index, and if it is a closing parenthesis, we'll pop from the stack, and if the stack becomes empty, we'll push the current index as a marker for potential invalid start. Calculate the valid current length using the difference between the current index and the stack's top value, and finally we'll update it with the maximum length. So let's dry run this approach using this example. So initially we'll store the -1 inside our stack, and we'll run a loop inside our string. So initially the value is 0 at index 0. Our character would be opening character. So we'll push the index of the opening character into the stack. So 0 goes into the stack. And then again we found an opening parenthesis. We'll push the index of it inside the stack. Same goes with index 2, which has a opening parenthesis. So we'll push its index value inside our stack. So finally, when we reach at index 3, here we found an closing parenthesis. So we'll pop it from the stack. So our stack stop would be 1, which is index 1. So we'll calculate the length of it. The length would be here 3 minus 1, which is 2. So from here index 3, we'll calculate the length 2 here, which includes the current index 3 as well. So 1 and 2. So this would be our valid parenthesis of length 2 here. So since we iterated over all the string, we found our value 2 here. So in this case, our answer would be 2, and we'll return 2 from this example. So another example here, which I have taken here, is of length 4, would be if here the starting index has an opening parenthesis. So we'll push the index 0 inside our stack, and again we'll found an opening parenthesis. So we'll push index 1 inside our stack. Here we found an closing parenthesis. So we'll pop the value from the stack and we'll calculate the length. So here length would be 2 minus 0, which is the top of the stack. So we'll update the maximum length with 0 and 2. So our current maximum value would be 2, which is from index 1 to 2. So again we'll iterate over the string. Here we again found an closing parenthesis. So we'll pop the value from the stack. So our stack top would become -1, and we'll calculate the length here. So it would be 3 minus of -1, which would give us 4. So we'll update the maximum length here, which would be 2 comma 4, and finally we'll get a length of 4. And here the valid substring would be from 0 to 3. So in this way we'll calculate the maximum valid substring parenthesis using a stack based approach. So here time complexity would be O of n, as we are iterating over the string only once, and space complexity would be O of n, as we are using an external data structure stack here. So in this way we have optimized our approach and decreased our time complexity way further. So let's code this approach and let's submit again. So here's the optimized version of code. Here I've taken the size of a string. I've used a stack of int as it stores the indices of each and every string. We have maintained a max length variable which will store the maximum length of the valid parenthesis. I initially put the -1 value inside our stack to handle the edge case, and I have iterated over the string. If it contains opening parenthesis, we'll push the index of it, or else we'll pop the value from the stack and we'll calculate the maximum length from it. So after popping the stack, if the stack remains empty, so in this case the second example will be a great case here. So if the stack becomes empty, we'll store the index value of the closing parenthesis where the invalid parenthesis order would start. So in this way, we'll maintain the maximum length here, and finally we'll get a value in max length which would store the maximum valid parenthesis. So let's compile and run this. It's working, so let's submit. As you can see, this problem got solved successfully as well. Here we have optimized our approach and brought according to our expected time complexity and expected space complexity. So this is it guys for this video. I hope you like this video and explanation. So please give it a thumbs up, share with your friends and subscribe to my channel, and please do check out other videos from our playlist. So until next time, keep coding and thank you.